In section 10.4, we're going to be looking at ratios between perimeters and areas when we have similar figures. There's really just two ideas that we need to know from this, and that's right here. If we have two similar figures, whatever the shape, if the ratio is A to B, then the perimeters are going to follow the same ratio. The area between these will change a little bit. The ratio will change by squaring that ratio, so it'll be A squared over B squared if we're talking about the areas. Okay, this is why that works. Let's say we have two similar figures where, let's say I start with a square x and x. If I double the sides, that would give me a side of 2x and a side of 2x, which means my perimeter is now going to be 8x. Notice I've doubled all the sides, so that doubles my perimeter from 4x to 8x. So my ratio of sides is x to 2x, that's 1 to 2. And my ratio of perimeters, okay, so sides, my ratio of perimeters is also 1 to 2. But with area, notice doubling the sides actually increases this so that I now have 4 squares. Or if we think about multiplying to get my area, that would be 2x times 2x or 2x squared. And so my ratio between these things, we had our original area of x squared. It's now over 2x squared, which would also be 4x squared, okay, because we have to square the 2 there. The x squareds could cancel out, and that gives me 1 over 4. Notice that the top is 1 squared, the bottom, 2 squared is 4. Same thing would happen if we triple the sides here. Okay, if I think of this as x and x, this would be 3x and 3x. The perimeter then is just going to be tripled. So instead of 4x, I now have a perimeter of 12x. And so I still have a ratio of 1 to 3. Okay, x 1 to 3. My area, though, has increased by 9, so it's 9x squared. And so my ratio from the areas, I would square that. The first one was 1, the next one is 9, or 3 squared. So they might give us two figures and say, what is the ratio of the perimeters? Well, to look for the ratio of the perimeters, we really just need to compare the sides. They ask smaller to larger, so that would be 6 to 9. We'll write it as a fraction, which would be equal to 2/3. That's the ratio of the sides. It's also the ratio of the perimeters. The ratio of the areas, though, we would take that and we would need to square each one. That's going to give us a ratio of 4 to 9. In this example, we're given the area of the smaller one, be here, and we want to find the area of the larger one. I'll call that A. So first we want to look at the ratio of the sides. If we look at the ratio between the sides, that's going to give us a ratio of 4 over 10, or we can reduce that to 2/5. To find the ratio of the areas, we want to use that same ratio, except we need to square it. And so that's going to give us 4 over 25. So looking at the ratio of my areas, okay, I'm looking for the one that was given to me. The smaller one was 27.5 over the area that we're looking for. And I put the smaller one on top because it needs to be equal to this ratio here. So we know the ratio of the small area to the large area is equal to 4 over 25. So I could cross multiply that and divide to get about 172. It would actually give me a decimal value, but I'm rounding. In the next example, we're only given the areas, and we're just asked to find the ratio of the perimeters. We're also asked to find the scale factor. Now what we can find here is the ratio of area, which will be 50 over 98, which we can simplify to 25 over 49. Now since we're working backwards, if we want the scale factor, we're going to take the square root of that, which will give us 5 over 7. Okay? Because if we square this, that would give us 25 over 49. So this will both be our scale factor and the ratio of the perimeters.